In 10.4, we are talking about inscribed angles and inscribed polygons. So an inscribed angle okay, let me write that better. Is an angle whose vertex is on the circle. So basically it has to be on the edge of the circle and contains the chords of the circle. The inscribed angle is half to the intersecting arc and central angle. So what that means, if I drew a circle and had a point P, the inscribed angle is an angle that starts here, could touch anywhere, but it has to touch, each part of that angle has to touch the edge of the circle. And with that angle, the purple angle being the central angle, and if I call this A, D, M, we can say measure of angle ADM is half of that of measure angle APM. Also measure of angle ADM is half of the measure of the angle of the arc AM, meaning this arc right here. It's half that arc. A polygon then is considered an inscribed polygon. When all the vertices lie on the circle. So if we had another circle, and as long as the points, the vertices, lie on the edge of the circle, this is considered an inscribed polygon. That pentagon is inscribed in the circle. So let's try it out. So we want to find the measure of BD. And here the measure of BD, the arc BD is here. It is 25 here. It is, that inscribed angle is half of arc BD. So BD is 50 degrees. BD here is this angle. So we want to find the inscribed angle that matches it. So the one that's all the way on the other side, which is the 52 degrees. 52 is half of that, so we double it. So that is 104 degrees. BD here, we'll choose BD as this part right here. And we focus on the opposite, which is the 70 degrees. So 70 degrees is half of BD, so that is double 70, so it's 140 degrees. Okay, let's try, now we want to find measure of angle C. Now they give us BD. BD is 150. We want to half it to find the inscribed angle. So half of 150 is 75 degrees. Number 5, angle C is here. We don't know what this missing side is, so we take 360 because the circle has to be 360 all the way around. So we take 360 minus 140 minus 100, which gives us 220. So then this is 220 degrees. Half of that going into angle C is 110 degrees. So then this is 110 degrees. Okay, we want to find X and Y. This is a little bit more difficult, but we can always use our thinking caps. So here, this is 108 degrees. That means this whole thing here has to be twice that. So that whole thing is 216 degrees. And if I take 360 minus 216 degrees, that gives me 144 degrees. So this here, all the way around, is 144 degrees. Angle X is an inscribed angle of the 144 degrees. If you notice that angle X is on the other side and its points start at the 144. So we take the 144 and we half it. That gives us 72 degrees, which is X. If X is 72, we know from our sum of all polygons, the interior angle, that a quadrilateral has to add up to 360 degrees. But if we forget, we can say 4 minus 2 times 180, that gives us 360 degrees for all the interior angles of a quadrilateral. So we have X, we have 72, and we have 108. So we take 360 minus 108 minus 72 minus 72, and we'll be left with Y, which is then 108 degrees. So Y is 108 degrees.